A over B, and A and B are integers, that says integers, and B cannot equal 0. You cannot have a 0 in the denominator. So basically any number that you can write as a fraction when A and B are integers, positive or negative whole numbers. You're not going to have a decimal in a fraction. So if you can write any number as a fraction using positives and negative whole numbers and not 0, then that's a rational number. So some subgroups of rational numbers include whole numbers like 0, 1, 2, 3, 4, all the way to positive infinity. And integers are positive and negative whole numbers. So whole numbers are positive, integers are positive and negative whole numbers. If it's not rational, then it would be irrational. An irrational number is the numbers that are never-ending decimals and non-repeating decimals. For example, so non-ending and non-repeating decimals. If you have a repeating decimal, that's going to be a rational number because you can write a repeating decimal as a fraction. But non-repeating and non-ending, so things like pi are going to be irrational because they go on and on and on. A non-perfect square root, so the square root of a number like 50, the square root of a number like 50, that is not going to be an ending decimal and it's not going to repeat. It's going to be 7 point something, 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 and so that would be an irrational number, the square root of 50, the square root of a non-perfect square. If it's a perfect square, it's going to be rational, like the square root of 49 is 7. So that would be an integer, a whole number, and a rational number. So let me show you what I mean by these, rational, irrational. So I'm going to slide you over. All right, example 1, copy this down. Tell if the number is rational, integer, whole, or irrational. So sometimes numbers are going to belong to different groups. So let's take A, 1, just 1. Well, we know that it's a whole number, so we're going to write whole. We know it's an integer, so we're going to write integer, and it is rational. So the number 1 belongs to all of those, whole number, integer, and rational. Now 1/3. It is not a whole number, and it's not an integer because it's a fraction, but it is rational because it's written as a fraction. And this, as a decimal, is 0.33333 repeating, so that shows you that repeating decimals are rational numbers. All right, C. The opposite, so the negative is on the opposite square root of 25. So the square root of 25 is 5, and then the negative is on the outside. So this would be an integer and a rational number. An integer and a rational number. And then D, the square root of 30. This is not a perfect square. It would be 5 point something. So this is an irrational number. Irrational number. So that's how that works. So you have to figure out what group it goes into. And if it's a whole number, then it's also going to be an integer and it's also going to be a rational number. All right, example 2, copy that down. Write the fractions as decimals. So we're going to practice converting fractions to decimals. And you might know how to do this. If you do, great. A fraction is a division problem. A fraction bar means divided. This means 5 divided by 11. So we want to change it to a decimal. We are going to have to divide. 5 divided by 11. Now 11 won't go into 5, so we need to add a decimal and a 0. And 11 will go into 50 4 times. That's 44. And I subtract and I'm left with 6. So I add a 0. I bring it down. 11 will go into 60 5 times. 5 times 11 is 55. And I'm left with 5. Going to add a 0. And notice I'm back at 50. So what I think is going to happen, I think it's going to repeat 50, 60, 50, 60. So let's just do it just to make sure. 11 will go into 50 4 times. 4 times 11 is 44. And I'm left with 6. And then I'm right, it's going to keep repeating, 4, 5, 4, 5, 4, 5. So this is a repeating decimal. And just in case you've forgotten, a repeating decimal is written with bar notation. So 0.45, and the bar goes over both numbers because both numbers repeat. Both numbers repeat. Whichever number repeats, that's what gets the bar. Now example B, 7 divided by 20. So 7 divided by 20, you're going to add a decimal and a 0. And you're going to divide 7 will go into 20 3 times. 3 times 20 is 60. And then we're left with 10. Add a 0. 20 will go into 105 times. And then we're done. So 0.35, 0.35. Now, there is another way you could do this. I'm going to show you with C. With both B and C, your denominator is a factor of 100. So that means it could go into 100. If you can get a denominator of 10 or 100, then it will be a little quicker. So let me show you. For this one, we want a denominator of 100. So in order to get 25 to 100, we had to do times 4. 25 times 4 is 100. And whatever you do to the bottom, you do to the top. So 8 times 4 is 32. So this decimal would be 0.32. That is totally acceptable. Another way you could do it, and it's correct. This one you would have done times 5. 20 times 5 is 100. So 7 times 5 is 35. So you tried D. Pause it. You tried D. All right, so this, I can't think of how to get 6 to 100. So I'm going to divide. 1 divided by 6. I add a decimal and a 0. 1 times 6 is 6. Now I'm left with 4. 6 will go into 40. 5, 6 times. 6 times 6 is 36. And I'm left with 4. 6 will go into 46 times and 36. And I'm left with 4. And I don't know if you can see that, but it's going to keep going. And the only number that's repeating is the 6. So your answer would be 0.16, and the bar is going to go over the 6 because the 6 is the number that repeats. All right, example 3, copy. Write the decimals as fractions. So now we're going to go backwards, and for most people, they say this is easier. However many digits your decimal number goes out, that's how many zeros you're going to have on a multiple of 10. So 10, 100, 1,000, 10,000. So for this one, this is 4 tenths. 4 tenths. So we're going to take it and we're going to do 4 over 10. And then we want to simplify. So with our fractions, we always want to simplify. Divide by 2, and we get 2 fifths. All right, B, negative 1.905. So the negative 1 is your whole number. So this one's going to be a mixed number. So negative 1. And then 905 is your numerator over 1,000 because this is in the thousandths, tenths, hundredths, thousandths. Plus there's 3 digits, so I know I need 3 zeros. I can simplify by dividing by 5. And that is 181 over 200. All right, so I put it over 1,000 and then I simplified. Letter C, 65 hundredths. So 65 hundredths. And then we can simplify by dividing by 5. And 65 divided by 5, 5 will go into 6 one time, and there's 1 left over, so 15. So 13 over 20. Now you try D. Pause it, and you try D. All right, so that's a whole number, negative 1 and 7 tenths. And then 7 tenths is reduced, so that would be your answer. Easy one. All right. Last examples, copy that down. Hope you can see the orange. Sorry, I was getting my markers. Okay. Ordering numbers from least to greatest. For most minds, it works best if numbers are in decimals. For most. If you want to change all these to fractions and then find a common denominator, go for it. But I think it will be easier if you just convert them all to decimals. So we already have 2 that are decimals. So we need to convert these 3. Now, I know that I could divide them, but if I can get an equivalent fraction out of 10 or 100, I'm going to do that. So this one is 6 tenths, and this one is because I got that by saying 5 times 2 and 20 times 5. So this would be 0.6 and 0.55. Now 2/3, I can't just do that as quickly, so you can divide, and you see that 3 will go into 20 6 times, 18. 3, so you're left with, 2, bring down a 0. 3 will go into 20 6 times, and that's 18. So it's going to be a repeating decimal, 0.6 repeating. Okay, so I know that was quick, but I just showed you how to do that. So now we can put these in order, and the least up here is going to be 0.51. And then the next one is going to be 0.55, so 11/20. Now remember, you need to write it in your original form. And then the next one is, this is 0.6, and this is 0.66. So 3/5, 0.62, and then 2/3. So that would be your answer in original form. So let me go over this last example. You're going to write these numbers from least to greatest. And so again, you putting them in decimal form is probably the easiest. And I want you to practice this one. All right, this one's going to be a you try. All right, practice this one on your own. And then here is your answer. -1.43. Now remember, negatives are going to be, the least is really going to look like the biggest. -1 3/7. -1 4/15. -1 1/8. And then -1.1. And that's really your biggest number. So let me know tomorrow if you have questions about this you try. And we will work more with fractions and decimals tomorrow. Bye.